Okay. Now, it's a 2-problem quiz tomorrow, but I have 8 practice problems. I'm not going to do all 8. We'll do 4 of these. The other ones on your own, I'll give you the answers.
And I put the work back in there. And I told her, are you going I came back to the microwave and just, it's like,
Alright, so everybody get one? Alright, so here we go. Like I said, we're going to do the front side, but it is really 2 different quizzes, old quizzes. You will have to do 2 problems tomorrow. I will give you the answers to the back side, and you can do those on your own if you wish. Okay, so here we go. I'm on the side that says 1. 1 and 2. So we're finding the cosine of negative 2 pi over 3. All right, lots of things are going through our head right now. What's the first thing we'll probably want to do? Change it into degrees. So how do we do that? We'll have a baby calculator. How do we do that? 180 times 2 divided by 3, right? So we're going to get negative 120. Okay. Let's see, Fatima got here. Anybody else sneaking in? Okay. So now what? What do I do now? I've done my first step. What do I do now? Ooh, we're in trouble tomorrow.
Make like the compass.
I draw a picture. So since this is regular math, these are my labels. Oh, but wait a minute, it's negative. So how do I handle negative?
Upside down.
Go the other way. So negative 90, negative 180, negative 270, okay. Then I figure out where negative 120 would be. Wouldn't that be in here? Right now, there's negative 120 right there. And then I make my butterfly bow tie triangle. Right? Now, what's the next thing? I have to figure out, this is the key to the whole thing. That guy right there. It's called the reference angle, and I need to find him. So I'm just gonna use my common sense. Oh my goodness. If this is 120 and this is 180, then the angle in between them is going to be 60. And if that's a 60, then I know I have a 30, 60, 90 triangle. Across from the 30 is 1, the hypotenuse is 2, and the other side, or that other side is root 3. Okay. Now what else do I have to consider?
Find out what's negative.
I gotta figure out what's negative, that's right. So looking at where I am, like 3, what's negative?
1
And the root 3? And now after all that, I'm finally ready to answer the question. What is cosine? I need the cosine. That's what the question is. Find the cosine. So what's cosine? Adjacent over hypotenuse. This is your angle. Isn't that negative 1 over 2? So your answer is negative 1 over 2. All right. Next, tangent to pi. All right, so we're going to go through basically the same steps. So what do we do first? Change it into degrees. So isn't that the tangent of 360? Now what is different about this problem than this one?
It's
Positive.
Well, it's positive, okay, yeah, but it's,
You need to do a
Circle.
circle.
You got
I need the circle because it's on the line. Isn't this, I know it's 0, but isn't it also 360? Because it's all the way around? So here is my angle, it's right on the line. So I have to draw a circle anytime my angle is on the line. So what are the angles that end up on the line? 0, 90, 180, 270, right? Anytime you have one of those, you're on a circle. What is the radius of our circle? 1. So what are the coordinates of the point? Here's the origin. I'm going right 1. 1, 0. That means that x is 1 and y is 0 from that point right there. Now I need tangent. Y over x. Tangent is y over x. So if I put y over x, I literally get 0 over 1. And when the 0 is on the top, it's 0. So I'm gonna write down 0 answer my okay, so this is what your quiz is going to be tomorrow. We're gonna practice one more time. Let's practice number 2. Problem number 2. Or quiz number 2. Okay, so we're going to have secant pi. All right, step 1. Degrees. So secant pi will be secant 180. Uh-oh. Uh-oh. Isn't that right here? 180. So that's another circle. The radius is 1. I need to figure out my x and y. This is the point, very good. -1, 0. Because think of plotting it on graph paper. Did we go left 1? Secant, okay. Secant is the reciprocal of the cosine. Cosine is x over r. So secant is r over x. Right? So r over x, oh wait. So r over x will be 1 over -1, which is simply -1. And then finally, sine 2 pi over 3. Step 1. Change it to degrees so you know where to graph it. So 2 pi over 3 is 120. Where is 120? Between 90 and 180. Make your butterfly bow tie triangle. You need an angle inside the triangle. You need the angle made by my fingers right here. What is the angle made by 120 and 180? 60. I know that angle right there is 30, but I don't want that one because it's not even in my triangle, right? You've got to pick the one that's in the triangle. So, 30, 60, 90, I can label the sides. Because across from the 30 is 1, across from the 90 is 2, that hypotenuse is 2, and the opposite is root 3. Anything negative, I have to remember to check that.
The 1.
The 1's negative. What's sine? Sine is opposite over hypotenuse. So won't that just be root 3 over 2? Right? Alright, let me give you the answers. To the ones on the back. Real quick. So for quiz number 3, the answers are 0 and root 3 over 2. For the bottom quiz, the answers are negative root 3 over 2 and 0. So you can do those on your own. The quiz tomorrow is 1 problem. Okay, I mean 2 problems. One of these quizzes that we just did. Okay? Also, before I forget, next week is a cereal drive. I've got announcements, I've got information about it in Canvas. It is worth extra credit. And I wanted to mention, last night I had to go to a wake at St. Augustine's, Little Sisters of the Poor, you know, that over by River. And we provide, our Camp Food Drive supports the Little Sisters in the fall. So since I was there, I was chatting with Sister Michael, our contact. She brought this big, a dynamo. And I told her we were having a cereal drive, and I mean, she was very, she almost started crying when I said, "We'll give you some cereal, you want some cereal?" And she was so appreciative. But because of the population there, it's a home for the elderly, and because of that population, Rice Krispies, Raisin Bran, Cheerios. So when you're bringing in, I don't care what you bring, because we're also going to provide the food pantries for children. So if you want to bring Fruit Loops and Apple Jacks and whatever, that's totally fine. But if you don't know what to buy, if you're standing there and you don't know what to buy, Sister Michael, Little Sisters of Four, Rice Krispies, Cheerios, Raisin Bran. Okay, but whatever you bring is fine. Whatever you bring is fine. Full-size boxes. Okay, or 12-pound box of Pop-Tarts counts as a box of cereal. So you can either bring in cereal or you can bring in Pop-Tarts. Have to be 12-pound boxes. Okay,
What's the max now of those points?
2 boxes max.
Okay.
So 2 points max.
Oh,
Yeah. And that's collection Monday, Wednesday, Friday next week. It's all the in-person Canvas. Please read it. And bring your cereal. It's for a very good cause. This thing was started years ago by a family. They all graduated, and the master department said, we're not gonna let it die, so we keep doing the cereal drive to support mostly homeless children, but we also support a few other things. Okay, let's get our notes back out. We are going to finish up 4.3. So the 4.3 homework will be due on Monday. Okay, everyone? 4.3 homework is due on Monday. Here is the last problem. This is one of the tricky ones. So before we even start, would everybody agree that always positive, so it doesn't matter where I am, the hypotenuse is going to be a positive number. If I am in quadrant 1, this is positive and this is positive, right? Everything is positive in quadrant 1. But if I'm in quadrant 2, this is negative and this is positive. In quadrant 3, that's still negative, but this is also negative. Right? And then in quadrant 4, that's still positive, but this is negative. So keep that in mind, draw it if you need to. I think that might help you approach this problem. These problems are a little tricky. It says the cosine is negative 3/5. Now forget the numbers for 1 second. The cosine is negative. What is cosine? Adjacent. And isn't the adjacent the x side? Isn't this the adjacent side right here? Draw just one of those triangles. Isn't this the adjacent side on the x-axis? So here's an adjacent side and here's an adjacent side. These are the adjacent sides. I need it to be negative. Can it be over here? Is adjacent negative over here? Doesn't have to be over here. So I have already narrowed it down. It has to be either quadrant 3 or 4. Because that is the only way that the cosine will be negative. If you draw that triangle, the cosine will be positive. If you draw this triangle, the cosine will be positive. It has to be over here. For the cosine to be positive, or to be negative, it has to be over here. Now I also need the tangent to be positive. So I only look at these two now. Which one of these will have a positive tangent? What's tangent? Opposite over adjacent. So let's look at this quadrant right here. If I put opposite over adjacent, will that be a positive number? It's positive over negative. Is that positive? This says the tangent has to be positive. Guys, you're starting to wig me out here. Positive over negative is not positive. Right? How about negative over negative? Okay, so I'm not in this quadrant. I have to be in this quadrant. Because this is the only quadrant that has a negative cosine and a positive tangent. Process of elimination. You have 4 quadrants. Start reading them out. So this problem is in quadrant 3. The cosine is negative 3/5. Oh, cosine, negative 3/5. Now what do? I figure out the quadrant. I have my picture labeled. Now what do I have to do? Pythagorean theorem. So 3 squared plus something squared equals 5 squared. 9 plus b squared is 25. I got 4, but it's actually negative 4. And I want to find the tangent. Here's my picture. What's the tangent? Negative 4 over negative 3, which becomes positive 4/3. Remember, we wanted a positive tangent. tangent, we got it. And then what is cosecant? Reciprocal of the sine. Sine is opposite over hypotenuse, so it will be hypotenuse over opposite. Or negative 5/4. Remember when you write the fraction, you can put the negative anywhere you want. So I put it on the top, you can put it on the bottom, if that makes more sense to you, 5 over negative 4. Okay? Alright, before we start our graphing, you don't have to write this down, I just want you to help, I want you to walk me through this. We want to do like that. Let's say we know that the tangent is 5/12 and the cosine is 8. And we want to find, I don't know, we want to find the cosecant and sine. Okay? So let's start narrowing it down. Here are our options. These are all of our options to start with. I need the tangent to be a positive 5/12. So I need the tangent to be positive. Okay? So which quadrants could that happen in? I heard somebody say that could happen in the first quadrant, right? Could it happen anywhere else that the tangent would be positive? The third. And why is the tangent positive in the third?
Because both are
They're
negatives.
both negative. So tangent is opposite over adjacent. So this quadrant won't work. And this quadrant won't work. So we narrowed it down. This is a positive number. So I'm either gonna have 5/12 or negative 5, negative 12. That's what I'm gonna have. Now, I also need the cosine to be negative. Well, it sure as heck cannot be quadrant 1, because what do we know about quadrant 1? Everything's positive. So it can't be quadrant 1, therefore my triangle is again in quadrant 3. Because the tangent is positive and the cosine is negative. Okay? Now, how do I finish? What do I do now? That's the hard part. The hard part's figuring out where you're at. Now what? Pythagorean theorem, 25, 40, 47, 13. Using the Pythagorean theorem. And then I can answer. Let's do sine first. Sine is opposite over hypotenuse. So the cosecant is hypotenuse over opposite. Right? So those are for sure thought-provoking problems, but you can figure it out if you just go one step at a time. One step at a time. Okay. Now we're gonna switch gears and we're gonna graph. Sketch one period and list the period and amplitude for each. What in the world does that mean? Well, sine. You hear it? Sine. Before I start screaming at you, I'll make sure it's not me. It is whatever's got the little UV lamps on, would you turn it off? Making me anxious. Hear it? I'm not gonna scream at you, just go turn it off. Sign is one of our BFFs. Anybody remember anything about what the sign looked like? You didn't have to memorize specifics about it, you had to memorize its general shape. It went like this, right? What else was special about it?
Went through the whole.
It went through the origin. So the sign is the one that looked like this. Now, it actually, I'm just gonna dash it in, but it actually keeps going forever and ever and ever. Both directions. Never stops, keeps going forever. But, we generally don't draw it forever and ever and ever, because once you draw a hill and a valley, everything else is just the same. It's another hill and another valley, and another hill and another valley. This is called a periodic function. It repeats itself over and over and over again. And the blue piece is called the period of the function, because the entire thing is made up of a hill and a valley, and then another hill and another valley, and another hill and another valley. So this is called the period. Now, your job is to figure out what is the period of this function. In other words, what's that label right there? No, it's easy. This thing, the sine curve, comes off of a circle. That's why it's like curvy like that, because it's like unraveling a circle. How far is it all the way around the circle? 360 degrees. Guess what, guys? If I went around my circle, drew my picture, what would happen if I went around my circle again? Wouldn't I get the same picture? That's what it means to be periodic. It just keeps repeating. Every time I go around the circle, I get another hill and another valley. So when we draw signs, we are only going to draw one hill and one valley. There's no point in drawing anything extra. We're going to draw one hill and one valley. And the period of the sine curve is 360 degrees. Once around. Because we let the radius of our circle be 1, the height of the curve, it goes up 1 and down 1. That is called the amplitude. The height of the hill is the amplitude. Also have to label some other things at this point right here. Anybody want to take a wild guess what that point will be labeled? How many degrees? 180, of course. That's halfway around. And then you have to label the high point of the curve. Any idea what that would be? 90. And then you have to label the low point of the curve. 270. What are these angles, guys? These are the angles when you label your axes. Aren't these the axes lines?
Yeah.
So there you go. That's your sine curve. That's it. That's what you should grab. Where it says sketch 1 period right there. That's what you sketch. Cosine, we are going to sketch the exact same thing, except what he remembers what's different.
I have a question for
Yep.
the last one. We have to to put for like amplitude or amplitude and the perm on the quiz perm on like the test?
Yeah, you will always have to know what the amplitude and the period are. Yeah, because they're gonna be changing here in a minute, we'll see. All right, I'm gonna sketch a cosine. Who remembers the difference, Gabby? Doesn't start at the origin. Where does it start? Up here at 1, that's exactly right. So you're still gonna have your hill and your valley. And I'll go ahead and extend it. But when we draw it, we're gonna draw from the top of the hill to the top of the next hill. That's what we're gonna draw. That's one period of the cosine. This, it ends at 360, just like the sine does. It's exactly like the sine, except it doesn't start in the same place. Its period is 360. The period of the sine and the cosine is 360 degrees. One time around the circle. The amplitude of the sine and the cosine is 1. So when we draw our hills and valleys, we go up 1 and down 1. Yep. Well, it is, for the standard sine cosine amplitude 1. We're gonna be changing the amplitude, but it is always positive. The amplitude's gonna be positive every time.
So when that changes, that like be because the x is different in the problem?
The x will change this. The number out front will change this, just like before, back in chapter 1, where that was. But let's finish our cosine first. We'll do something. Right smack dab, okay, so the cosine starts at the top of the hill, stops at the top of the hill. Right smack dab in the middle would be the bottom of the valley. Does that make sense to you? So that would be 180 right there, the bottom of the valley. Then these two, where the hill ends and the valley starts, or vice versa, what would these two labels be? 90 and 270. That's exactly right. Okay? These are your standard, regular old sine and cosine. Okay? Good? Because now I'm going to throw the tangent at you. That was not a BFF, and it looks different. So let's get a tangent up. Do you remember when we were doing those circle problems? Sometimes our answers came out to be undefined. Remember? That doesn't happen with sines and cosines, but that happens with other things, including the tangent. So, the tangent looks totally different because it has asymptotes. So the tangent has an asymptote at negative 90 and positive 90. It goes through the origin. It's a squiggle. So it kind of looks like a BFF. What BFF does that look like? Do you remember? Cube. It looks like that, except it's got asymptotes. The cube doesn't. This is your basic standard tangent curve. Now we can change some things about it, but this is what we start with. This is our basic. Tell me about its period. Tell me about how wide it is. Remember, the period was start to finish. So it's 360 for the sine and the cosines. Is it 360 for this? No. How far is it? 180. The period of the tangent is 180. I warned you when we started all this that there was a lot to memorize. There's a lot. How about amplitude? What did we say amplitude was? The height of the hill? Well, first of all, there's no hills in this thing. But second of all, is there even a height? No, why not? Because there's arrows, right? So is that defined? It's undefined. We usually just say empty set or write the word none, but I wouldn't argue with undefined. That means it doesn't exist. The tangent will never have amplitude because this is what it looks like. No matter how we change it, it's still going to go up forever and down forever. Okay. Look at letter D. But now you have the basic curves drawn. So now we're going to start changing them up a little bit. So we're going to sketch y equals 2 sine. Okay, now, first thing I think when I see this problem is I go, what does a sine look like? A sine looks like this. That's what a sine looks like. The normal labels for a sine are those. I know I did that fast. When you have graphed as many of these as I have, you'll do them fast too. But your key is right there in your notes. 90, 180, 270, 360, those are your labels. On that one. That is my normal sine curve. Everybody in agreement? Now I gotta figure out what's changed. Because when I put a number into the problem, either these labels are going to change or these labels are going to change. The shape isn't going to change. A sine curve is a sine curve, but the labels will change. So the number that we put in is a multiplier out in front. Remember what that guy does? That guy changes your height. This guy multiplies your height. And in trigonometry, height is referred to as amplitude. So what have we done? We've multiplied our amplitude by 2. So these labels are not 1s. Now these labels are 2s. So in effect, haven't we stretched our curve? Right? What's an amplifier? What does an amplifier do? Turn up the louder, right? Makes those sound waves taller, increases the height or the amplitude. That's what these are, they're like sound waves. And you just turned up the volume. You made it louder. AM radio, amplitude modulation. That's what AM radio is. Amplitude.
What's FM?
FM is frequency modulation, and frequency is the reciprocal of the period. That is a little bit beyond the scope of our class, but that's what it is. It's a reciprocal period. Okay, so amplitude is 2, period is still 360 degrees. We did nothing to change the period. All we did was stretch it this way by a factor of 2. Okay? Next, -3 cosine. what a cosine looks like. I'm gonna sketch it up here. This is what a cosine looks like, right? Starts at the top of the hill, stops at the top of the hill. That's a cosine. One period of it. What has happened in this problem? I see some of this going on because we remember that when we multiply by a negative, we turn our curve upside down. So a normal cosine starts at the top of the hill and ends at the top of the hill. Well, if you turn that upside down, where are you starting? The bottom of the valley. You're making a hill and you're ending at the bottom of the valley. Remember, you end where you started. So if you're telling me I'm starting at the bottom of the hill, then I'm going to be ending at the bottom of the hill. Now the normal labels, and the normals don't change, guys. The normal labels don't change. They'll be what they are forever. But when you stick a number in there, then you change your labels. So what's happened? We've turned upside down, and we have multiplied by 3. So this is now 3, and this is -3. If we were doing this on graph paper, wouldn't that one be 3 times taller than a regular one? I'm not gonna worry about all that with you guys, just label. Change those labels. What's your amplitude? 3, positive. Amplitude and period are always positive. Amplitude and period are positive. So it's 3, and the period is still 360. I haven't changed it. Okay? Now we got a tangent. Tangent is the funny looking one. I'll go ahead. This is my tangent curve. For tangent, we don't have any labels on the y-axis because we don't have any amplitude, right? So it's just -90 to 90. That is my tangent. But I am sketching negative tangent. Well, quiz tomorrow. There's practice. All right, what do you think? What happens when I put a negative out in front? Turns it upside down. Upside down. This isn't upside down. Okay? Now wait a minute. A normal tangent, asymptote, starts down and ends up. That's normal. If I turn it upside down, it's going to start up and end down. Does that make sense to you? Haven't changed the labels. Just flipped it upside down. What is my amplitude? This is a tangent curve. What is my amplitude? None. What is my period? 180. Haven't changed it. It's still 180. Not too bad. All right, let's look at the next one. Y equals sine 1/2 x. sine curves look like. Sine curves look like this. And oh shoot, I forgot what chord it is, so periods are short. Doggone it. Well, this will have to wait until tomorrow. So we take our quiz tomorrow. How many problems on the quiz? 2. You have extras to practice if you want.